Hello, welcome to Carl Sandburg College. My name is Gene Beetler. I'm an instructor here, and due to situations beyond our control, i.e. the coronavirus, we are doing an online lab for our class this week. Today we're going to talk about valves, how they pertain to the hydraulic system. We have a variety of things to look at here. There are three main types of valves we're going to discuss today. We're going to discuss pressure control, direction control, and volume control. Now, when we pertain to pressure control, we're going to look at relief valves and pressure compensating valves. When we talk about direction control, we'll talk about spool valves and the type of valves that will change our directional flow. And then we're going to talk about volume control and how it pertains to flow control. Here we got some examples of some relief valves here. I have a direct acting relief valve in this spool valve, and I have a pilot operated valve in this valve assembly from our school here. First we're going to take this one out and take a look at it. This relief valve is used on a spool valve here. It's a direct acting relief valve. Those are used on a low volume system where you don't have a lot of flow going through it. They are good for quick response, and they offer shock relief. For full flow systems, we're going to probably use a pilot operated one, but this is a simple relief valve that does the job. It's adjustable by means of some shims and an adjustable screw on it. I'll put that back in there so I don't lose it. Okay, so that's that type of relief valve. Very simple, not too much to it. If we want to go to a system that uses more higher volume, and the main thing about a pilot relief is it allows us to run our pressure very close to where we want to be at the maximum setting without losing it. When this one here goes off, it drops our volume, our pressure off way dramatically, so you don't get the control of it. It's too quick responding. This one here is a lot more finer adjustment. When you unscrew this, you can see in there. On the relief valve, it's maintained by a small spring inside. The key thing with a pilot operated relief valve is we're able to maintain close to our relief pressure and operate our system without dropping big drops. As I said before, this direct acting relief valve has larger drops in pressure when it relieves its pressure, system pressure. This one here will maintain a small amount of pressure right there at the relief setting, and you won't lose that large drop. So we don't have a great heat buildup in the system. This here can build up a lot of heat when it goes off. This one here does not. And since we can maintain that pressure differential over a tighter area, we now end up with what's called a tighter override. So our system stays at or near maintained pressure where we want it to be. When we use relief valves, of course, we're working with open center hydraulic systems. Now, when we go to a closed center, we don't need to use a relief valve, so we're going to push that out of the way for a little bit. On a closed center system, this particular one here is a axial pump. It's disassembled because I don't have all the parts for it. It was a componentry piece that I found. This pump is a variable displacement pump, and this particular one is actually a load sensing closed center hydraulic system pump. We actually have a load sense valve on the bottom here. We have a pressure compensator on top. The compensator is going to be hooked up to the hole right here. Now you got to realize this is the crankcase pressure that's built up inside of here, and we use a small port, a hole that drains off some of the crankcase pressure to the head of it, which is mounted here, above it, which isn't connected directly to the pressure side. And we're going to bleed off a constant amount of oil back into that crankcase. So when our system is activated and flow is sensed on a normal closed center hydraulic pump with just a compensator valve, if we did not have this load sense, it would be stroking the pump when the pressure inside the crankcase drops due to the fact that it comes directly off the main manifold pressure of the pump output. So when this area here drops pressure because the other the output line dropped in pressure, it's going to stroke the pump because this is going to activate this top valve here. It's hooked up with a drill port down to it, and that's going to stroke the pump and make it go to full stroke. Now, this one is in bad shape, so I can't push that swash plate and make it angle real well. I can a little bit, but it's not real clear to you on the camera, but that's how that works, as we discussed in our pump section. But now when we go to this pump, we now also add a load sense. Now we're going to talk about the volume control in a bit, because that is directly proportional to volume control. But I just wanted to point out that the pressure control valve is going to be used to control pressure on a closed center hydraulic system like we have here. Okay, we have a spool valve here that I've actually removed from a feed truck a number of months back. It has some problems, you can see right here. This is a detent cap on it, is all corroded and ate up. That's due to high salt content and acidity of the feed it was using around it. If you rotate it around, you can also see some etching there from the same thing. It's just the aluminum housings were susceptible to the corrosion from the feed. Now the main cast iron surface is kept pretty good shape. I got this thing out so I could utilize it, and we're going to disassemble it. This actually relief valve came from this, of course. I noted one thing when I utilize it, that the detent is a little bit catchy. So obviously some corrosion is built up inside of this little detent cap here, and it's one of the reasons why it was removed out of service. Now we'll disassemble it and take a look at what we got here. This side of the valve, we have our inlet port, sits right here. Okay. On this side we have our outlet port. As I said earlier, this is an open center hydraulic valve, so we know that we have to keep a flow going through it in neutral position. We have our two work ports mounted on top, one here, one here. So to describe this valve, it is a four-way, three-position valve. It does not have a float position on it. Now we'll tear it apart. Okay, first of all, we got our outlet port. I wanted to point out the O-rings. Each of these valve stacks have a matching O-ring boss built into one side or the other, and then the other side is smooth material, so it seals against it. Okay, once again on the valve we have the bores for the O-rings in the side of it. The other side, of course, was a smooth side. So this plate here has got the smooth side on it. So you always match the smooth with the O-ring side. Let's go ahead and take this apart and see what we can find with it. First, we'll go ahead and remove the lever and the linkage control for it. Next we'll remove the Allen screws that hold the plates on. And our detent cap is the same way, still running okay. Now, due to the fact on a detent cap, if you try to remove it from the spool valve, you're going to be chasing a spring and two little check balls around the shop, and we don't want to be doing that today, so we'll just leave it attached for now. This is the spool valve. It's got the lands and grooves for the oil. It's self-lubing. It doesn't require in the center of it any sealing because it's a metal-to-metal seal, and the coating of oil in the little grooves provides only seal necessary. The only seal that is required on it is the one for the end plates where the O-rings are. You have a retainer. I'm going to pull this one here off. What's this? Got it? This is the retainer that holds the O-ring in place. Underneath the retainer you have a little backup sealing ring right here, and then the O-ring is right inside of there. After I remove the retaining ring, this is the backup ring on this particular model. And then we have the O-ring right here. So it's all simple seal. There's nothing too elaborate about it. Inside the bore, there's the bore of it right there. Can you see down in there? Okay, I think it's all right. All right. Nothing too damaged in here, just a little bit dirty. Otherwise, it's okay. Now we'll remove our load checks. Okay, next valve is our load checks or our lockouts. It's when we have a spool valve, there's always a little bit of leakage that goes through it. Now, I want to point out a couple things about these. Look, this is a simple check valve. They don't come out. There's the spring. There's the valve. Okay. Load checks or lockouts, just a simple lightweight relief valve. And since the pressure is always going to push them out, we have to have some way of holding that oil from leaking back. So what we do with that case is we'll pull out both of them, and I'll get you a view from the inside of it. You'll see how it works. With both of our load check valves removed, we have oil that's going to be pressurized from both sides when it's in the neutral position, so the valve is going to be equalized, and so it'll be held in the check position, in the closed position. When the lever is moved on one side, it allows oil from the other side, which is still pressurized, to push the opposite check valve open, and therefore you end up with flow, and it opens up. As soon as you let go of the valve or you go back to neutral, that valve is able to lock back out. This enables to have a safety measure from free fall of a device that's in the air, like say a boom or a mast or something up in the air, and it creates a little bit of back pressure. It will not allow it to flow backwards through the system. Okay, with that, we've disassembled this valve as far as we can go, so now we're ready to reassemble it. We'll reassemble in the reverse order we took it apart. We'll first load our load checks in. I'm not too worried about torque on these particular ones because I'm not going back into service with this. I keep all this together. Okay, now we got to put this together. You can actually install this end plate with the linkage bracket, either position, upside or downside, depends on the application of your unit. For this one, I leave the lever in the vertical up position, but on some cases I have seen them in the down, and for the application it depends on how it's located on your truck or your implement. Now with that put on, we'll go ahead and install the assemblies back to the end plates. Lastly, we'll install a relief valve.
Yes.
Now we've completely finished our valve. This is the end of our 4-way 3-position valve. So now we're going to move to a little bit different one. Like I said, this is for an open center hydraulic system with a relief valve. Next, I have a valve that came off a closed center hydraulic system. This is much different design, but similar in a lot of ways. The spool is inside, going through it still. Well, this one has quite a bit more features on it. This has a flow control. This one is also load sensing. And this one right here. And so this valve is now, we're going to change it from a 4-way position valve, a 4-way valve, to a 5-way valve. And we also have 4 positions because we have a float assembly in this detent. It can drop to the float position as well as drop. As I said, it had a flow control on it. We roll it over. We now have another valve here, a feature. This is a zero leak function. It actually holds its remotes up better, and it's not supposed to leak down. However, I've had some trouble with this one. One of the reasons why it's out of service is it tended to want to leak down. After a little bit of work on it, I found out the problem wasn't in the leak down function, but what the problem with this one was, I'll get this valve back in there, set back in there so I don't lose it. This spool, if you rotate it a quarter of a turn, it changes things. And so when the cable was hooked to it, we had a problem with the spool had actually rotated a little bit, and it was actually creating a leak inside of it. I'm going to take this valve off this pump housing here. Okay, after removing our valve assembly off of this, we have 3 small ports going into the pump body, the pump housing. The rear pump housing port is actually our port that drills straight down through to the crankcase. That tells our compensator whether or not it's dropping pressure inside the crankcase. Okay, the front port is actually the one going to the cylinder of the head of the pressure of the actual pump housing. That's our actual output pressure. And the center one is our load sense port. It's hooked directly to it's our signal line going to our swash plate, our servo piston for our swash plate. So that's the center one. The front one is remember our pressure from our pump output, and this is the pressure of the actual crankcase. So we can control this pump by both flow of the load sense and the pressure output from our pressure control valve. Let's remove our load sense valve from it. Take a look at what we have here. It is adjustable. We have an Allen and a lock nut, a little set screw. Okay, there's a small valve that's screwed back into the load sense on the back side of it. Underneath that, we have a spring, actually a dual spring, and a small plate that seats against that valve that lays up in there. It sticks out, it protrudes out into that. And inside there we have actually a little shim in there. You can remove it out if you want to, I think. No, not coming out. It looks like it's in a groove. Oh, I see. The two halves of that come apart. No big deal. All right. So that's what we have there on that part for the load sense valve. Okay, next we remove our pressure control valve, in this case also known as a compensator. So again, we got a spring, double spring, a little spool valve, and another set-in valve in. Okay, little spools that go inside there do come out. So what you have is a little seat for that spool, a spring, and so that's how that goes in and out and adjusts. So that's for your load sense. Here's for your compensator. Same way, it's got a little seat for it to set on. A lot softer spring. I can actually move that one. The other one's a little stiff. I couldn't quite move that one. And now you have the valve here. You can look down inside it and see what you can see. Okay. Alright. Okay, I want to identify some of our valves that we use on our test bench here. This is a common check valve. Nothing too elaborate about it. This is a fully compensated flow control here valve. Look at adjustable. Oops. Let's remember how to get that thing. Yeah, there it is. There we go, that locks. Next I have a sequencing valve. It's a valve we can operate one sequence of one cylinder, then when that cylinder is full stroke we can start the other one going. This here is a pilot operated, fully compensated pressure control valve. It's got a port for a gauge and several functions it can do. So we're going to build some activities when we get back to class, and hopefully we'll get to our lab before the end of the semester and be able to work some sequences and some tests out on our test bench. Thank you very much.